raw direct IO and also non-blocking IO. Just the term raw IO means we are issuing IO directly to disk offsets, bypassing the file system cache altogether. You may hear of this because sometimes, a long time ago, applications have said that raw IO performs better than file system IO because the application has its own cache, and its own policy of operating the cache, which can pay attention to application context. And we just don't want to pay the file system tax. We want to let the application write to disk directly and manage it. Oracle Database was a key example of this, where it used to recommend doing raw disk partitions. But it's a bit of a pain for the system administrator, because if you're hopping between systems and some of them have these raw application partitions, you don't see them in df-h and you don't see them in the standard files. And it can be a bit of a maintenance burden. How do you back it up? Well, I can't use my standard OS tools. I have to go to the application. How do I do statistics on it? Like, how full is it? Well, I can't use my standard OS tools. I have to go to the application. If you had lots of different applications doing this, it would be a real headache for the system administrator. And so there are advantages to actually paying the tax and sticking it in the file system, because then I get all my metrics, I know how to back it up and restore it, all that stuff. A middle ground was something called direct IO, which allows an application to use a file system, but bypassing the file system cache. It's like synchronous reads. It's not as direct as raw device IO, since you still map file offsets to disk offsets. But at least it's a real file system that you can manage and monitor and all that stuff. ZFS has historically not been interested in implementing either, because of the ZFS performance design. It's designed to be high-speed performance such that either doing raw or direct IO is not necessary. So I know people would like to go to town and benchmark that and try to prove it wrong, which would be difficult to do because benchmarking itself is a difficult thing to do properly and accurately. But on ZFS so far, we have not implemented that type of call. Non-blocking IO we mentioned in the application chapter, and that's when you can issue an IO to the file system and you don't have to wait for it to complete. You can continue doing your application code. And so that's when you set a flag to be O non-block or O end delay for the open system call. And of course, Node.js has really popularized this type of IO.